Alright, so we are going to look at this question over here, which is slightly tougher as it has a cube root here and it really involves a bit of chain rule here, just a heads up. Alright, so let's start this question when we are going to differentiate the following with respect to x, where y equals to cube root, the whole thing 3x plus 2 sine square x. Alright, so first things first, remember the two steps that I told you. The first step is to always find out where is the x, alright, in trigo differentiation. So this here is your aka your x. Okay, so now what we are going to do, right, is to make sure that it is in a nice form to differentiate. That is the second step. Alright, so now let me ask you this question, yeah? Is it in a nice form to differentiate or not? Not yet at the moment, right? We can't differentiate first, but actually if you want to differentiate, it can, but it'll be very, very complicated. Alright, so I would rather you to make it into a nice form, like maybe like in a like an index form, you know what I mean? So cube root, what can we change it to? Remember this rule in indices where we learn in E-math, where we know that if we cube root x, this will be x to the power of 1/3. Alright, where you have an invisible 1 here, so this is 1/3. Alright, so we can apply the same to this, where we will rewrite our y as 3x plus 2 sine square x to the power of 1/3. Alright, so from here you might wonder how to do now. So let me ask you this question. What kind of differentiation is this? This kind of differentiation is a chain differentiation. Alright, because why? There's the power 1/3 here, which shows that it's a binomial. Alright, okay, so now what are we going to do now? Remember the steps for chain rule? There are 3 steps. Power number come down, power number minus 1, and then you differentiate the inside bracket. Alright, so let's start by differentiating now. And one more question, ladies and gentlemen, is it okay to differentiate right now? Yes. Okay, so dy over dx, so this will be equals to 1/3 power come down bracket 3x plus 2 sine square x, and then 1/3 minus 1. Let me press in the calculator, yeah? This will be negative 2/3. And now, ladies and gentlemen, we will differentiate the inside bracket. So when we differentiate the inside bracket, right, what is it? Alright, so we know that this over here, we got two terms, right? This term and this term over here. So this one, what do we know? We know that this term over here is a basic differentiation. And we know that this term here is a trigo differentiation. So remember your 4 steps for trigo differentiation, yeah? Power number come down, power number minus 1, and then do your trigo differentiation and you differentiate the inside bracket. So moving on to this differentiating of inside bracket, as it is a rule that we have to apply in chain rule differentiation. So what will we do? Differentiate the inside bracket, yeah? So basic differentiation, let's start. Alright, so when you differentiate 3, what do you get? You get 3, right? Because basic differentiation, power number bring down, power number minus 1. Alright, and then do notice that there's a power 1 over here, yeah? So 3 times 1 is just 3. Why 3 times 1? Because you bring the 1 down. So it's 3 times 1, which is 3. And then power number minus 1. So it's x to the power of 1 minus 1, which is equals to x to the power of 0, which is 1. Therefore, 3 times 1 times 1 is just 3. Alright, so now let's start to differentiate our trigo differentiation, where we add the plus sign first. So is there a power at the 2 sine square x? Have, right? So we will bring it down. So 2 times 2 will be 4. And then power number minus 1. Alright, so power number minus 1, we will get a sine x. Alright, so when we differentiate sine x, now this is the part where we will do your trigo differentiation. So when we differentiate sine x, remember this, d over dx sine x. This will give you cosine x. Alright, so just write a cosine x here. And when we differentiate the inside bracket, it's just a 1. Alright, so I'll write the 1 here for you. But in the exam, try not to write it and we close the bracket. Honestly, why do I say don't write the 1 is because it is redundant in my opinion. But for you guys to understand better, I will write it out. But in the exam, save time, don't write. If you want to write, it's okay also. Just watch out for your time management, yeah? And you want to write it out for yourself to secure the marks. You know that you 100% secure it, do it. I'm not going to stop you here. Okay? So, now let's start to simplify. So, this will be equal to 1 over 3 bracket 3x plus 2 sine square x to the power of minus 2/3. And then we will write out our next differentiating the inside bracket part. 3 plus 4 sine x cosine x. Okay, so now when we are doing this part, right, what will we do now? We will write our final answer. So remember, whenever you see negative power, bring it to the denominator. Therefore, one more line will be 3 plus 4 sine x cosine x over 3 bracket 3x plus 2 sine square x to the power of 2/3. Okay, so you can leave your answer as like that. Or you can write it what I'm going to write in pink. Or you can write it as 3 plus 4 sine x cosine x over 3 bracket, square root, cube root, 3 plus 2 sine square x, the whole thing square. Both of these answers will be accepted in the exams. Okay, so do take note that both are accepted. But for me, if you ask me, which one will I write? I will write the one in blue. Good enough already. Okay, because you want to change to square, cube root, square root is even better. You can do that, and this shows that you really know your indices. You want to impress the examiner or whatever. But either ways, if a student give me the answer in either blue or pink, I will accept the answer. Both answers are accepted in the exams, so do not worry about getting your marks penalized. Okay, you will not be faulted for that, as you have differentiated correctly and you have used the right methods like chain rule, trigo differentiation. You know, you got all the methods there, all is shown, you know, so marks will be awarded for that. Alright, so you might wonder, why did I write 3 plus 4 sine x cosine x on the numerator? It's because I times this in. This can be equivalent to 1 over 3 times, okay? So I'm not going to write out everything. I'm just going to add it at the bottom. Or if you want, I can write it out for you. 1 over 3. This is the same thing. So I write this out is to only show you that it can be expressed as like that if you are unclear. But I bet you guys understand what I'm trying to write here. And once again, this is the full working for solving this differentiation question. And once again, thank you very much, ladies and gentlemen, for watching this video. And this video will come to an end, and we will stop on chain rule and polynomial trigo differentiation over here. And in the next video, we will be looking at specifically special trigo identities, and we are going to learn how to differentiate them. Alright, so heads up first, ladies and gentlemen. What will we be learning in the next video? We will be learning how are we going to differentiate, let's say, cosecant x. Maybe let's say cosecant square x. We will be learning how to differentiate this secant cube x. We might even learn how to differentiate cotangent 4x. Alright, heads up for now, ladies and gentlemen. Alright, so this is for the next video. Alright, so don't worry so much, ladies and gentlemen. I'll be going through with you all this step by step in a very clear process. Don't worry about it, ladies and gentlemen. Alright, and I'll see you in the next video, and I really hope you understand this question over here. And please always remember to practice your differentiation, as differentiation is one of the more commonly tested in O levels. It can take up 20% of the whole paper, and including integration as well. Okay, so without further ado, I'm gonna end this video here, and I'll see you in the next video where I'll be looking at how are we gonna differentiate special trigo identities.